How much time does it take to come to rest if your initial velocity is 5 meters per second and your acceleration is -2 meters per second squared? The first step for solving a problem like this is to write down the given information. So off to the side here, we're going to write a column for our givens. And now we're going to go back to and reread the problem, picking out all the relevant information. How much time does it take to come to rest? So this tells us that the final velocity of our object is going to be 0 meters per second if your initial velocity is 5 meters per second. So v0 is equal to 5 meters per second, and your acceleration is -2 meters per second squared. So a equals -2 meters per second squared. Now the problem is asking for how much time does it take. So we want to solve for t. Now we have our three kinematics equations. V equals v0 plus at. V squared equals v0 squared plus 2a delta x, and x equals x0 plus v0 t plus 1/2 a t squared. Now, of these three equations, the one that we are going to use, once again, will be v equals v0 plus at, because these are the two equations down here, again, are dependent upon position, which we are not given. So these two are irrelevant for our problem. So the only useful equation that we can use is v equals v0 plus at. Now, we're trying to solve for t. So instead of plugging in all the givens right now, we're going to use some algebra to switch this around to solve it in terms of t. So we're going to subtract v0 from both sides. So we get at is equal to v minus v0. And then we're going to divide both sides by a. So t is equal to v minus v0 over a, which we can now plug in our given values to solve for this. So we got v, our final velocity is 0. Our v0 is 5 meters per second. And our acceleration is -2 meters per second squared. So this would give us a time of, if we carry out the subtraction here, we would get -5 meters per second divided by -2 meters per second squared, which would give us a total of 2.5 seconds. So our time is 2.5 seconds. Make sure when you do this problem that you don't forget a negative sign somewhere. Remember that your time can't be negative for any type of these problems. It just isn't right. So make sure you wind up with a positive value for time, because time's not a vector, it's a scalar. It doesn't depend on direction, so there's no time in a negative direction. It's, in this case, scalar, so it has to be positive. So just make sure you wind up having that, and if you do have a negative here somewhere, go through back here and check, make sure you didn't lose a negative somewhere.